بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله. This is section 6.2 compound interest. In the previous section we discussed simple interest and we have seen that I equals to PRT. A second method of paying interest is the compound interest method, where the interest for each period is added to the principal before interest is calculated for the next period. So with compound interest, both the interest added and the principal earn interest for the next period. So for the first period, the principal will be there only. For the next period, the principal and the interest for the first year will work together for the next year. So the principal grows as the interest is added to it. For example, let us discuss this case. $20,000 invested for 3 years at 10% compounded annually. So when we say compounded annually, the period here is 1 year. So this means that the ending principal for each year becomes the beginning principal for the next year. This is always true, of course. So here in the first year, we started by $20,000. What was the simple interest rate? It was 2,000. So the ending principal or the future value after 1 year would be 20,000 plus 2,000, so 22,000. So this 22,000 would be the principal, the beginning principal of the second year. This is not like the simple interest. Simple interest, if 20,000 works for 3 years, then every year, the beginning principal would be 20,000, no change. The interest does not added to the principal. But here compounded, when we say compounded annually, this is what we mean. We add the interest to the principal. So 22,000 will work for in the second year. And their interest, their simple interest in a year would be 2,200. And then we add 2,200 to the beginning principal, and we have an ending principal of 24,200. And now this 24,200 will be the beginning principal in the third year, and so on. So this is what we mean compounded annually. So the ending principal or the future value, how can we find the future value immediately? Can we have the future value immediately here? Remember that we said that S is P plus I and I is PRT. So you take P as a common factor, you have 1 plus RT. And if we are talking after 1 year, if T is 1, then S would be P plus 1 plus R. So here always S would be P times 1 plus R. So in this example, R is 0.1. So if we multiply the principal times 1.1, we will get the future value immediately. So in the first year, 20,000 was the beginning principal. Multiply by 1.1, you get 22,000, which is the future value after 1 year or the ending principal at the end of the first year. Now in the second year, we need to multiply this 22,000 by another 1.1, or we are multiplying the original amount 20,000 by 1.1 times 1.1. So this is at the end of the second year, future value at the end of the second year. at the end of the third year, we will have this one, which is also 20,000 times 1.1 to the power 3. So we can say that after n years, okay, compounded annually, the formula would be 20,000 times 1.1 to the power n. So this would be the future value if P is compounded annually. So P amount is invested at an interest rate of R, annual interest rate, expressed as decimal as usual, compounded annually. Then the future S would be given by this formula. So here 30,000, 3,000, which is the principal, is invested for 4 years. So this is T at R 0.09 compounded annually. So this is not a simple interest. The simple interest here would be 3,000 times 4 times 0.09, 1,080. But if the money, if P is compounded annually, we will get more interest. How much interest is earned? Let us see. So the future value would be P, which is 3,000 times 1 plus R, which is 0.09 to the power n number of years, which is 4. And the amount, the future value would be 4,234.74. So the interest, in this case, the compound interest, would be the future value minus the present value, and this would be 1,234.74, while the simple interest in 3 years is 1,080. So there is a difference between them about $154.7. I hope you understand the difference between compounded annually and the simple interest. Now, some accounts have the interest compounded semi-annually, not only annually, maybe quarterly, monthly, daily. So unless specifically stated, a stated interest rate, or called nominal annual rate, is denoted by R. So R is the annual interest rate, or they call it stated interest rate or nominal annual rate. All of these are names for R. So this, if we are per year, rates per year. But if there are periods, if we are compounding semi-annually, then there will be periods, and we can find interest per period, interest rate per period, which is I. And of course, we can find I if we divide R by M, where M is the number of compounded, okay, compounded semi-annually. M would be 2, compounded quarterly, M would be 4, compounded monthly, M would be 12, and compounded daily 365. So I is the interest per period, where I is R over M, is the nominal rate, which is R, divided by the number of interest periods per year, which we will call it M, the number of interest periods per year. The interest periods are also called conversion periods. and the number of periods is denoted by n. So n is the number of periods. How can you find n? N is the product of the interest periods, which is m times t, the number of years. Okay, so n would be m times t. T is the number of years, and m is the interest periods. So if we multiply m times t, we get n, which is the number of compounding periods. So the interest rate per period is I, and the number of compounding periods is n. An example, 100 is invested, so this is P, for 5 years, this is T, 6% compounded, so this is R, this is R. Compounded semi-annually twice a year, so M is 2. It has been M is 2 for 5 years, so N would be 2 times 5, which is 10 periods, the number of periods. And I, the interest rate per period, would be 6%, which is R, divided by 2 because M is 2. So it would be 3% per period, interest per period. The future value, to find the future value in this case, we use this formula. So it's 1 plus R, but now we don't have R, we have R over M, which is I, the interest per period. And N now is not only the number of years, N is the number of periods here, which is the interest periods M times T, the time in years. For each of the following investments, find the interest rates per period, I. So we need to find the interest rate per period and the number of compounding periods, N. So in A, the definition of I is R over M. So 20% compounded monthly, 20% is R compounded monthly. So the number of interest periods will be 12. And then when we divide 0.12 over 12, we just get 0.01. So 1% per period, the interest would be 1%. The interest per period is 1%. What about the number of compounding periods, N? Well, it is M times T. M, the interest periods, which is compounded monthly, so it's 12 times T time in years, which is 7. So the number of periods in this case would be 84. In each year, it is compounded 12 times because monthly. Part B, I is 7.2%, which is 0.072 compounded quarterly, so it is over 4. So it's 0.018. This is the interest per period, per one period. And the number of periods is quarterly, so 4 times 11. But this is not 11 years, this is 11 quarters. So N in this case is just 11 number of quarters because the period here is quarter. Okay, he did not say number of years like here. He gave the number of quarters. So that's the answer. That's N. Jim and Eden wants to have $200,000 in Mora's college fund on her 18th birthday. So this is the future value they want to have. And they want to know the impact on this goal of having 10,000. So if they invest 10,000 at 9.8 compounded quarterly on her first birthday, to advise Jim and Eden regarding this, find the future value of 10,000 investment. So the future value of 10,000 investment would be P, which is 10,000, times 1 plus compounded quarterly, so R, which is 0.098 over 4 quarterly, to the power 4 quarters quarterly times the number of years. How many years? On her first birthday, so after 1 year, they will put the amount of money, and they need the money on her 18th birthday. So 18th minus 1 is 17, so they will invest 10,000 for 17 years. So just multiply 10,000 times 1 plus 0.098 over 4 to the power 4 times 17. The answer is 51,857.7, 51,000. What is the amount of compound interest that the investment earns? Compound interest is the interest here. It's not simple interest, this is compound interest. And the compound interest, as simple interest, is the future value minus the present value. So it would be 41,857.7 if you subtract 51 minus the 10,000. So what is the impact this would have on their goal? Well, it would be very good for them, okay? Because if they just put 10,000, after 17 years, they will get about quarter of the money they need. So if they can manage to put 40,000, they will get all the amount they need after 17 years. Well, the beginning principle is the principle, we call it P. It is also called the beginning principle. It is also called the present value of the investment. So P is the present and S is the future. So let us have some questions. What amount must be invested now? So he's asking about P. To have 12,000, so this is S. After 3 years, this is T. If the money is worth 6%, so this is R. Compounded semi-annually, so this is M. So we have the future value. It is equal to the present value times 1 plus R over M to the power M times T. And to find P, you can simply divide 12,000 by this. 0.06 over 2 is just 0.03. If you add it to 1, so you just have 1.03. So I can just write it 1.03 to the power 6. So if you divide 12,000 times 1.03 to the power 6, you will get the present value, which is $10,049.8. So this is the present value. The future value is 12 and the present is 10,49. Well, here this figure shows 3 years after Google stock was first sold publicly. Its share price had risen 500%. So this is the 500%. Google's 500% increase means that if 10,000% invested in Google, so if this is P in Google stock, as its initial public offering was worth 600, so this is the future value for 3 years. T is 3 years. The question, what interest rate? So what is R? Compounded annually does this represent? compounded annually. So the formula is S equals P times 1 plus R to the power n number of years. So S is 60,000 and P is 10,000 times 1 plus R, which is known, n is which is unknown, to the power 3 years. To solve this equation for R, I divide first by 10,000. So 60,000 over 10,000, that's just 6. So 6 would be equal to 1 plus R to the power 3. And now what should we do? We take the cube roots of both sides. And then R would be negative 1 plus cube root of 6. And if you want to find uh, this as a decimal, use the calculator, and it is 0.817. So if you multiply by 100, this is 81.7%. So this is the rate this investment will give you per year. This is the interest rate, the interest rate per year. 5,000, this is P, is invested 6%, this is R. Compounded quarterly, M is 4. For 5 years, this is T. Find the number of compounding periods, M. Well, M is the number of compounding periods. That's just 4 because quarterly. Per year, the number of compounding periods per year. So that's just M. The number of compounding periods for the investment, not per year. So N would be M times T. You multiply by all the years. So 4 times 5, it would be 20. The interest rate for each compounding period I, well, I is R over M. R is 0.06. This is yearly, but if it is compounded quarterly, then I would be 0.06 over 4 or 0.015. So each period, this would be the interest rates per period. The future value. Well, the future value is S. What is P? P is 50,000. 1 plus I, which is 0.015, to the power N, which is M times T 20. So we can just multiply and find the answer. And the answer is $6,734.3. Find the present value, so that's P, of an investment that's worth, so this is S, after 5 years, this is T, 9% compounded monthly, so M is 12. So S is 12,000. P is unknown, 1 plus I is 0.09 over M to the power N, which is M times T. Okay. Now, how to find P? Yeah, I can find P by dividing 12,000 over. If I add 0.09 over 12 to 1, I get 1.0075 to the power 5 times 12 is 60. So I just divide 12,000 by 1.0075 to the power 60, and the answer would be 7 664.4. So this is the present value, and the future value is 12,000 after 5 years. All right. Now, if P is invested for T years at a nominal rate R, compounded continuously now. What if the compounded is continuously? The future value would be given by this formula using the exponential function. S would be P times e to the power RT in this case. So find the future value, that's S. If 1000, that's P, is invested for 20 years, that's T, R equals zero point zero 0.08 compounded continuously. Once he say compounded continuously, the formula is S equals P e to the power RT. So we need to find S. So we multiply 1000 times e to the power r times t, and we use the calculator to find the answer. E is there in the calculator. You it is above the len. So the answer is 4953.03 dollars. So 1000 will worth 4,953 after 20 years. Part B, what amount must be invested? So he's asking about P at 6.5 compounded continuously so that it will be worth 25,000. This is S. After 8 years, this is T. So S is P times e to the power RT, and S is given, but P is not, and R is 0.065 times T, which is 8. You can divide, of course, 25,000 by this, or you can just multiply 20,000 by e to the power negative 0.065 times 8, and that's just 0.52. So this negative means we are dividing. So I'll just multiply 25,000 times shift e to the power negative 0.52, and the answer is 14,863.01. So it's okay. This is what? This is the present value. What is the future value? 25,000. How much more will you earn if you invest 10,000 for 15 years at 8% compounded continuously instead of at 8% compounded quarterly? Okay, let us find the first investment. The future value in the first case would be 10,000 times e to the power r t, which is 15. So the future value in the first case would be 10,000 times e to the power 0.08 times 15, and the answer is 33,201.17. While the second method, 8% compounded quarterly. So this is the first case. The second case, compounded quarterly. This means that the future value in this case would be 10,000 times 1 plus I, which is R, okay, 0.08 over 4 quarterly M times to the power M, which is 4 times T. Okay, so in this case, multiply the 10,000 times 1 plus 0.08 over 4 raised to the power 4 times 15 or 60. And the answer would be 32,810.31. So how much more I will earn? Okay, 33,201.17 minus 32,810.31. So the difference between them will give you the amount of money you earn more. Okay, and it is 390 $390.86 more. Thank you very much. I'll stop here and I'll continue the section in another video.